Alright guys, in this video we are asked to solve the congruence 3x minus 9 congruent to 17 mod 31. So our goal in this process is to find x, right? But we want to find our x so that it's reduced mod 31. So we want to find x mod 31. So reduced mod 31. So we're going to solve for x, but then make sure that whatever our answer is reduced mod 31. All right, let's go ahead and do it. So our equation here, our congruence, is that 3x plus 9 should be congruent to 17 mod 31. All right, and the first thing that we can do is we can just subtract. So we know that addition and subtraction are perfectly legal operations in modular arithmetic, so this is totally fine. And what do we end up with? Well, on the left-hand side, we just have 3x. Congruent to on the right-hand side, we now have 8, right? So 3x congruent to 8 mod 31. 17 minus 9 is 8. And now at this point we end up with this congruence where we have 3 times x congruent to 8. If this were just arithmetic or algebra with real numbers, or even with rational numbers, we would just divide through by 3, right? And we'd say, oh, the answer is 8/3. But 8/3 is not an acceptable answer in a moduli space, right? So it doesn't work that way. What we need to do is instead of dividing, I should say, by 3, we need to multiply this whole equation by the inverse of 3. So we're going to multiply both sides of the equation by some number a, where a obeys this property, that a times 3 has to be congruent to 1 mod 31. All right? So our job right now is to find a. Well, how are we going to find a? One way is just by exhaustion. 3 is a small enough number. We can just start multiplying 3 times a whole bunch of numbers until we finally get one that has a remainder of 1 when divided by 31. Another way, which I think is better, is to find the Bezout coefficients. And this is definitely better when the numbers are bigger. But in this case, it's going to be really nice, right? So we want to find the Bezout coefficients of 3 and 31. So remember how this works. We first apply the Euclidean algorithm. So we divide 3 into 31. Goes in 10 times, right? The remainder is going to be 1. And then we're done, obviously, because the next step is to divide 1 into 3, but 1 goes into everything, right? So there's our GCD. By the way, it better be 1, right? They better be relatively prime if we're trying to find an inverse, and they are. So what do we end up with then? Well, we can say now that 31 is equal to 10 times 3, right, plus 1. But we want to rearrange this to solve for the 1, so this can then be rewritten as 1 equals 1 times 31 plus negative 10 times 3. All right, and the reason I wrote it like this is a negative 10 instead of a plus, or minus 10 here, is because this number right here, this is our Bezout coefficient of 3 mod 31. This number right here is the inverse of 3 mod 31. So that's exactly what we want. Now, negative numbers are a little weird, right? So we know that negative 10 has to be congruent mod 31. You can just add 31, right? It will have the same remainder. So this has to be congruent to 21 mod 31. And so at this point we can either use 21 or we can use negative 10. Negative 10 is a nicer number to work with. It's just going to give us a negative answer on the right hand side that we'll have to deal with, right? So let's do it. Let's use negative 10. Let's just see how it works with the negative number. If you want, you can repeat my argument with 21, right? So what I'm going to do now is multiply negative 10 times this entire congruence equation. So 3x congruent to 8 mod 31. All right, negative 10 goes through on the left-hand side. What's it give us? 1, right? We made it that way. We made it so that this is the inverse of 3 mod 31. So now we just have x congruent to negative 80 mod 31. And that is not going to be an acceptable answer. I mean, it's perfectly fine, right? It's correct, but it's not the one we're looking for. We want to reduce this. So this, when I wrote, find x mod 31, what I mean is that our x should live in this space z31. So it should be between 0 and 30, right? An integer between 0 and 30. And so that's how we want to get this. Now, to get that, what do? We can just start adding 31, 31, 31 to this to find the remainder, right? But 31 times 2 is 62. That's not enough, so we need to go one more, right? So we just do 80, negative 80. I'll just stack it up the old-fashioned way, right? Plus 93, subtract, you get 13. All right, so 13 is the answer that we want. So x is congruent to 13 mod 31. There's our answer. That solves the congruence. Notice we used the Euclidean algorithm, the Bezout coefficient method. We solved the congruence. Everything is good. We are happy, right? And then you can plug into here to make sure this really works. Let's check it, right? So 3 times 13 plus 9 is equal to 39 plus 9. That's 48. 48 minus 31 is, oh boy, 17. So now we can smile. Okay?